Okay, hello everyone. Welcome to my class. This is Sir Robinson, your partner in learning mathematics. Okay, in this video, we are going to review some of the basic concepts of trigonometry. Okay, because after this video, you are going to learn about the limits of trigonometric function. But before you proceed to limit of trigonometric function, you have to learn the basic of this all. And in this video, we are going to review some of the basics of trigonometric function. So we have here two objectives in learning. So first is we are going to learn about the sixth trigonometric function, and the second we are going to convert degree to radians and vice versa. When you talk about degree and radians, these are the numerals used in trigonometry or for the trigonometric function. I do everyone is very excited to learn in this review video. Okay. So these are the six trigonometric functions used. Okay, first is the sine. Sine, this is the first trigonometric function, and the symbol is sin or sine. Do not read this one as sin. Okay, this is sine. Second trigonometric function is cosine, and that is in the symbol cos or cos. For the third trigonometric function, that is tangent or tangent, that is in the symbol tan. Okay, for the fourth trigonometric function, that is cotangent, that is in the symbol cot. For the fifth, that is secant, that is in the symbol sec or sec. For the sixth trigonometric function, that is cosecant or csc. So in summary, these are the six trigonometric functions used. Okay, the sine, cosine, tangent, cotangent, secant, and cosecant. As you can observe, I put some variable inside of the trigonometric function because your trigonometric function cannot stand alone without this following, without the variable beside your trigonometric function. It could be sine x, sine y, sine theta, or any variable inside your trigonometric functions. Okay, so in every trigonometric function, we have this very important characteristic that we need to identify. So first characteristic is the co-functions. So in trigonometric or in the six trigonometric functions, each of this has co-functions to each other. Okay, so let's identify what are the co-functions of our trigonometric function. So let's begin with sine. Okay, the co-function of sine is, that is cosine. Again, the co-function of sine is cosine, and that is vice versa. The co-function of cosine is sine. Obviously, how are you going to identify the co-function of any trigonometric function? Just the clue there is the word co. Okay, co-function. So this is the first trigonometric function, sine, that is cosine. Let's proceed to tangent. What is the co-function of tangent? And obviously that is cotangent. Okay, again, the co-function of tangent is cotangent, and that is also vice versa. The co-function of cotangent, that is tangent. Okay, take note of this following characteristic of our trigonometric function. And lastly, the co-function of secant, that is none other than cosecant. That is the co-function secant, cosecant, and that is also vice versa. The co-function of cosecant, that is secant. That is the first characteristic of our trigonometric function. That is the co-function. Let's proceed to the second trigonometric characteristic, that is the inverse function. Okay, so inverse function, therefore, in the sixth trigonometric function, we have this so-called inverse to each other. Okay, so let's identify this one by one. Okay, so what is the inverse function of the sine? The inverse function of the sine, that is the cosecant. Therefore, sine and cosecant are inverse to each other, and that is also vice versa. The inverse of cosecant is sine. That is the first trigonometric inverse function. Okay, so let's begin with the inverse function of cosine. the inverse function of cosine is none other than the secant. Therefore, cosine and secant are inverse to each other. You have to remember that characteristic. And also this vice versa, the inverse of secant, that is cosine. That is the second inverse trigonometric function that you have to remember. Second is the inverse of tan, none other than cotangent. The inverse of tan, that is cotangent. And that is the third trigonometric inverse function. So that is also vice versa. The inverse of cotangent, that is tangent. Okay, so you have to remember all of this. That is the co-function and the inverse function, because as we saw that the trigonometric identity, these characteristics are very important. Okay, so in summary, what are these characteristics? In summary, so the co-function, sine and cosine, tangent and cotangent, secant and cosecant. And for our inverse function, we have the sine and cosecant, cosine and secant, and tangent and cotangent. For you to remember, because it is very easy to remember the co-function because of the word co or the prefix co, right? So for you to remember the inverse function, you have to draw it like this. I have the sixth trigonometric function, namely the sine x, cosine x, tangent x, cotangent x, and secant x, and cosecant x. As you can observe, that this is how I remember the inverse function. So inverse of sine is cosecant, inverse of tangent, that is cotangent, inverse of cosine, that is secant. As you can observe, I form a asterisk, right? So that's how you remember the inverse function: sine, cosecant, cosine, secant, tangent, and cotangent. That is how you remember the inverse function of the trigonometric function. Again and again, these are the characteristics, the co-function and inverse function, that are very important in solving the trigonometric function. Okay, remember this characteristic. Okay, so take note that all trigonometric function can be expressed as sine and cosine. Therefore, you can able to write the all trigonometric function, namely sine, cosine, tangent, cotangent, secant, and cosecant. You can able to write all of this as a function of sine and cosine. Okay, so meaning we can able to express this all. Okay, so say for example, this one. What does it mean that all trigonometric function can be expressed as the function of sine and cosine? Okay, so we all know that the first trigonometric function, that is sine x. The second trigonometric function, that is cosine x. And obviously, these two first trigonometric functions are already expressed as the function of sine and cosine, right? Third is tangent x. So how am I going to express this one as a function of sine and cosine? Remember this one, the tangent x is always equal to sine x over cosine x. Okay, so meaning through this one, I express tangent as the function of sine and cosine. Therefore, always remember tangent is equal to sine x over cosine x. That is for tangent x. How about for the cotangent x? How am I going to express this one as a function of sine and cosine? We all know from the definition earlier that the inverse of tangent is cotangent. So since tangent is equal to sine x over cosine x, what is the inverse of this one? What do you mean by inverse? You are going to interchange the position of your numerator and denominator. So by definition, we defined earlier that cotangent is the inverse of tangent and vice versa. Therefore, the cotangent as the function of sine and cosine is cosine x all over sine x, interchanging of positions. So therefore, for the cotangent x, we can able to express this one as cosine x all over sine x. And you have to remember that one. Okay? So second one is, how about for the secant and cotangent? cosecant rather. For the second x, how am I going to express this one as the function of cosine or sine function? We all know earlier that secant is the inverse of cosine and vice versa. So therefore, we can able to express this one as a function of cosine. So since secant is the inverse of cosine, therefore, this secant is equivalent to 1 over cosine x. And there we express secant as a function of cosine. Okay? How about for the cosecant x? That is cosecant x, always remember again and again that cosecant is the inverse of sine x. Okay, so therefore, we can able to express this one as 1 over sine x. And there, we can say that all functions can be expressed, or all trigonometric function can be expressed as the function of cosine and sine. So in a review, again, sine x, cosine x, tangent x is equivalent to sine x, cosine x, cotangent cosine x over sine x. How about for the second x, that is 1 over cosine x, and cosecant x, that is 1 over sine x. And there, we can say that all trigonometric function can be expressed as the function of sine and cosine. So you have to remember, these are the important characteristics of trigonometric functions. And we, again and again, these are the 6 trigonometric functions. Okay, so again and again, first objective of this video is to identify the first 6 trigonometric function, and those are the basics of trigonometric function, and we are done with our first objective. Okay, so now let's proceed without further ado, ladies and gentlemen. But before we proceed to the second objective, I do hope that you are all taking notes, okay? Because this is very important, that taking notes to remember everything, okay? So that is the first trigonometric function. Without further ado, ladies and gentlemen, let's proceed to the second objective of this video, that is converting degree to radians. Okay, this is now our second goal for today. Okay, so but before that one, let's first define everything. Okay, let's first define everything. So now we all know that in a trigonometric function, this one, in a trigonometric function, these are the numerals used in solving as such. We have the radians and the degrees. How are we going to differentiate these two? Radians, that is expressed as this one example, pi over 2, 3 pi over 2, 3 pi over 4. Okay, these are the example of radians. How about degrees? I know everyone is very familiar with degrees. These are 90 degrees, 180 degrees, 35 degrees, and 360 degrees. These are the numerals, or the numerical coefficient used in solving trigonometry. So meaning, since these are the numerical coefficient used for trigonometry, therefore, there may be some radians who has an equivalent value for degree and vice versa. That is our second goal, convert radians to degree and degrees to radians. Okay, so these are the formula that you have to identify, you have to remember in solving radians to degree and degrees to radian. As you can observe, if you still remember, I sent you a table of values for trigonometric function for sine, cosine, tangent, cotangent, secant, and cosecant. As you can observe, in the first row or column, you have the degrees form and you have the radians form. So how are we going to see the equivalence of radians in degrees? So these are the formula, converting radians or rad to degree, and also degrees to radians. So what are you going to do for the formula for the first one? That is radians times, this is not a variable, this is a multiplication operation. So radians times 180 over pi. And for converting degree to radians, that is degree, the given degree, times pi over 180. So as you can observe, we have only two formula, 180 degree over pi and pi over 180. Once the given is radians, pi is at the denominator. Once the given is degree, 180 degrees is at the denominator. That's how you remember that one. Okay, let's try in order for us to learn it more and more. Okay, so these are the examples. Examples number 1, let's convert the following. And obviously, the following is in the form of radians. Let's try to check what is its degree equivalent. So 5 pi over 6 and pi over 2. So let's convert the following into degrees form. As you can observe, the given are radians. So therefore, I have to multiply this one by, in order for me to cancel the pi, so that is pi over 180. Again and again, for in converting radians to degrees, 180 over pi. And obviously, we can able to cancel pi. So let's proceed to multiplication. 5 times 180. That is 5 times 180, that is 900. All over 6 times, that is 6. So meaning 900 divided by 6, that is 150 degrees. So therefore, 5 pi over 6 is equivalent to 150 degrees. Okay, that's how you convert that one. So let's proceed to second example. So that is pi over 2. Convert this one to degree. Let's find the equivalent degree value of this example number 2. So we have to multiply that one, same thing here. That is 180 over pi. Okay. So now, very obvious, we can able to cancel the pi. That is 180 divided by 2. That is 90 degrees. Therefore, 90 degrees is equivalent to pi over 2. That's how you convert that one. Again and again, the formula in converting radians to degree is multiply the given radians to 180 over pi. That's how you solve that one. So without further ado, let's proceed to second examples. So these are obviously the given are degrees. Let's try to find the value of this one given that the degrees, then convert to radians. So how are we going to solve that one? Again, these are the formula in solving such. So degrees to radians, your pi is located at the numerator and the 180 degrees located at the denominator. So let's convert this one into radians. So multiply this one by pi over 180 degrees. Same thing to example number 2. Pi over 180 degrees. Then you simply simplify, that is 90 degrees pi all over 180 degrees. You can able to cancel the degree now. So that is 90 divided by 180. That is 1/2. So meaning this is equivalent to as pi over 2. So meaning 90 degrees is equivalent to pi over 2. Simple as that. So let's try to find out for example number 2. So it will become 270 pi over 180. So let's divide 270 divided by 180, and that is 3 over 2. So it will become 3 pi over 2. So meaning this is now the equivalent of 270 degrees. The 270 degrees is equivalent to 3 pi over 2. So these are the objective of this video is to convert everything again and again. Do not forget the formula in converting this one. So that is the formula in converting this one. As you can observe, we are done. We are done with our objective of this video. Our objective of this video is to identify the 6 trigonometric function. Again, what are the 6 trigonometric function? Namely sine, cosine, tangent, cotangent, secant, and cosecant. And we have the 2 characteristics, namely we have the 2 characteristics, namely the cofunction and inverse function, and the co-function of sine is cosine, tangent, cotangent, secant, cosecant. And for the inverse function, we have the sine, cosecant, cosine, secant, tangent, and cotangent. And for the second objective of this video, convert degree and radian. What is degree and radians again? These are the numerical coefficients used in solving trigonometric function. And in solving that problem, you have to identify this formula. Okay, if you're still confused, you watch the video again and again. And obviously, we are done with our second objective of this video. Again and again, this is Sir Robinson Ipulan, your partner in learning mathematics. If you master this video, you can now proceed to the second video, and that is the limit of trigonometric function. Okay, see you in my next video. Bye-bye!